Welcome back, Lane. I'll next be teaching you about how to create custom classes. So in the last video, you learned about using existing classes like the NSString, NSDate, and those classes are provided by the iOS framework. So those are available to you to use, and it makes it really nice because with those framework classes, you can build really neat iPhone applications very fast by you writing very few lines of code and just leveraging the code built from Apple already in those framework classes like the NSString class. Uh, you know, like when you saw that, change to uppercase method, you were able to just use that string method without you needing to write any kind of special code to make that happen. So there's all kinds of uh, methods like that available that you can take advantage of by looking up documentation references. But sometimes you want to create your own custom classes. Like, let's say you're building an application for students and you want to represent a student with particular types of data, like, say, their name or age. And it's nice to be able to cluster those student objects in kind of a chunk of code in a way where the data is stored for that student, but also methods uh, that are associated with that particular student. It can really encapsulate concepts nicely so that your code is easier to work with. But furthermore, you can do inheritance and delegation and passing uh, references to these different custom classes. But let's just go ahead and get started. So I'll create a new Xcode project, and we're going to be making a command line tool again, application, and we'll just call this creating custom classes, or just a single class. Next. So again, we'll be working within main. And in this particular application that we'll be building, we'll be using, we'll be creating that custom class and then using that custom class here in main. So let's go ahead and do that. So I've actually made a diagram of what I kind of had in mind as far as our custom class. So we've got a custom class called student, and that student class will represent different types of data, but then also there will be methods available for that class. And that's what a class does. It contains data and has methods. And in this student class, we'll have a name method and a name data, age data, and there will be a method for learn. And then it will also calculate years until finish college. So that'll be another method. So I'll just put this aside and bring it back in a second. Or maybe we can leave it over here so it's visible. I'll just shrink that there. Make some more real estate. So we can see what we're trying to make. This custom class. So how we're going to do this is within our Xcode project, we open up File, New File, Objective-C class. This is within Cocoa Touch. And it will be inheriting from NS object. That's the base object. and we'll be just calling this student. Be sure to capitalize the first letter. Next, and we'll be placing this object within our project, this class within our project. And you see what's been created, a .h file and a .m file. So the .h is our header. This shows us where this shows us the declarations of the data, and it shows us the method declarations. But it's the .m file. That's where implementation happens. That's this file, and this is where the real meat and real complexity of the code is going to be taking place. And you can see in the .h file that our student class is inheriting from NSObject. So actually, all of the methods available in NSObject will automatically become available within our student class, such as that description method I was telling you about in our last video. So now, let's go ahead and try to use that within our main program. So, below this NS log, we can start writing some code. So let's try to use that student class. Okay, student. Oh, doesn't seem to be doing any code sense. My student. Oh, it's giving us an error. I mean, why can't we just start typing like that? Well, guess what? We need to import our custom class. So you see right below the import foundation, we need to import our custom class that we just created. So that student class is in our project, but it hasn't yet been imported into main. So we'll just go ahead and import student. And now it should be available to us. So let's try typing. Okay, student. Oh, see, it's doing code sense, and it knows it's even a class. So there's student. My student equals. And now what do we do here? So we need to allocate memory for this new student, because the computer needs a place to store the student. So we can say student, which is calling our class name, student alloc. So we allocate memory for this new object, this new instance, the my student instance. And it's going to have the form or the data and the methods for student. Allocate and then init. So we need to do that. So allocate and then initialize that student. So now we have the student available, my student. But then what can we do with this? Well, what if we want to say my student and then set the name? Is that working? No. It's actually giving us an error right here. It's saying property name not found on the object student. So we have our student object, but there's no name property. We haven't set that up yet. So we actually need to go to the header, and we make a property for the name to be placed. So we say property non-atomic strong, and it's going to be an NS string pointer called name. Now, what is this? So property is when we see at property, that's telling the compiler that we have a sort of a special thing happening to the code, where there's going to be a new variable set up for the class. And non-atomic, I'm actually not sure what that's about, but that's just what we do. We just say non-atomic and then strong, and then strong refers to the way it's handling memory. Like it could be weak, but if we call it weak, then it won't be sort of persisting in the memory. It might lose it. It might lose the data for that name property. So we need to say strong in order for that memory to be retained, so that it'll persist throughout the application without us losing it like accidentally through the automatic reference counting. Now this name data field is of type NSString, and that you've seen before. That's where we put our strings, our text. So we're going to be able to assign this student a name now. So let's try to do that. And because of some recent updates in the OS, we don't have to synthesize an implementation file this property. So that makes it easier for us. So now let's try to give my student a name. My student name. Okay, so we're gonna give the student the name Lane, which is your name. So that looks like it's working. We're not getting any errors there. We're assigning a literal string to the name property of my student. And let's just prove that worked. NSLog the student's name is, and then we'll put the %@ sign. That's a placeholder for a string. And we'll go ahead and pull that out. My student name. There we have it. The student's name is Lane. So it was able to store this name Lane for our instance, the my student. Now we also want to store age. So that's going to be an integer. So we'll add a new property. Oh, actually we don't need non-atomic strong. That's just for the pointer guys. So we'll just say int age. All right, that's looking good. We're not getting any red marks. And again, we don't have to synthesize. Now let's see if we can assign it an age. My student.age 18. So Lane is 18 here. And let's just make sure that it got it okay. So we'll say NSLog the student's age is %I for integer. My student age. And that way we'll be pulling out the age data. Yeah, the student's name is Lane. The student's age is 18. That's perfect. And actually, I have I've got a representation there of that instance. So this is the class. This is kind of the template structure for the object. But then when you create this instance, my student, so in fact this student here corresponds to this kind of template structure, and then this instance, my student, that's actually representing this guy right here, Lane. So that's how we instantiate objects. But let's go ahead and make another object, so you'll see another example of that. So we'll say student, so that's the class, and we'll just say sister of student, and we'll allocate memory for the sister. Alloc init, and then again, but let's use different notation here. So before we were using dot notation, so I'll show you another notation. So it's sister of student set name. So this property capability that we saw earlier, where we set the properties for the class, the name and the age, what it gave us is getters and setters. So we can set the name by using this dot notation like that, or we can do it by using this method called setName. It automatically, the property capability of the code, it gives us the automatic ability to set variable values with this sort of special keyword of saying set and then the variable name. So set name, and that's a method on the instance of the class. And your sister's name is Jelly. There, we were able to instantiate a new object, your sister, and then give it the name Jelly. Now let's do the same thing with age. So sister set age, and notice the code sensing it knows the proper syntax. So Jelly is 19. So now here we have two sisters. They're both students. We have Lane, which is you, who's 18, and your sister, Jelly, who's 19. So you're there together. And that's kind of what it looks like. So this student class, but then here, this corresponds to my student. This is Lane, and then sister of student, that's this one. Now we want to be able to write methods. So it's not just storing data like a data structure, but you're actually able to write custom code on that custom class. So now let's make a new method for this student class, and we'll say it returns void. So the method doesn't return anything. And we'll call it learn. Oops. And we'll just close it off. So the method is called oh. Okay, that's fine. So these are our methods. methods. And then this is our data for the custom class. So we have a method called learn. Now this learn method needs to be implemented. So we implement it in the .m file. So it's void. It's called learn. And then we put the implementation within the brackets. So let's just do a simple nslog. Nslog, say learn. I am learning how to program an iPhone. Close it off. So whenever we use the method learn on one of the student objects, it will print out this to the console. I'm learning how to program an iPhone. And notice also that we used a minus sign here, which means the method will be used on an instance. It's not a class level method. So we go back to main. So this is where we instantiated our custom class. And let's go ahead and cause you to learn. So we'll say my student learn. And that will cause you to learn iPhone programming because it will say I'm learning it. And I'll go ahead and run that. But I'll comment out the hello world. Okay, so we'll go run that. Look at that. The student's name is Lane. Wondering if that's a little small. It might be a little small for you to read. Let me see if I can figure out how to change the font there. Oh yeah, that might be nice. This is the color. Let's make it a little bigger. Yeah, I think that should be better. Okay. So now we see the student's name is Lane. The student's age is 18. And then I am learning how to program an iPhone. So it was able to load up that data into the custom class and then print out that data here. And then call the method learn. So this student's name is Lane. That's right here. The student's age is 18. There's that. And then learn. That's this. So that called this method. I am learning how to program an iPhone. I am learning how to program an iPhone. Okay, now let's maybe make a slightly more interesting method. So we go back to the methods. So we've created the name property, the age property, the learn method. And let's just do a little calculation. Years until finish college. So we'll have that return in integer. Years until finish college. And I'll just copy that declaration. And then we'll put that declaration into the implementation file. So within the implementation file, the data, like age, is available when we call self.age or bracket self space age close bracket. And so we'll just say int finish college age. Let's just assume people finish college at age 22. That's of course not always the case, but we'll just say for the sake of this example, everybody finishes college at age 22. And we'll create an integer years remaining in college. And that's going to be equal to finish college age minus self.age. So that's going to be pulling out the age property, and it's going to subtract that value from finish college age and calculate the years remaining in college. And finally, we want to return that in value. And that will calculate for us the number of years left for the student in college. Let's try to use that now. So we'll go back to the main file. That's where we're instantiating the object and then using the object. And I'll go ahead and comment these guys out because we're concentrating on a new one, but I'll keep the name. And and we'll just use that new method we made right there in the nslog. So we can say nslog years left in college. Will be an integer. And we'll just go ahead and call that. So my student years until finish college. So there we had our code sense. It knew that we had just created that method. Close it off. And let's see if it gets it. 4 years left in college. So it calculated your age, which was 18, and said, all right, years left in college, 22 minus 18, that's 4. So you see it's doing a calculation for us when we use that method. And you can imagine a whole series of different calculations to compute different things, like, you know, what if we had an input variable and said you studied abroad, like you decided to go to Europe and study in Germany for a year. That might cause you to extend your education so that you'll need an extra year. So that kind of variable input value could be inputted into the method to take that into account. Now, what if 5 years goes past, or let's just say 6 years goes by, and all of a sudden you're now 24. What's going to happen? -2. So it's giving you a negative number because by the time you hit 24, you're already done with college. And what if we didn't even set that value at all? What's going to happen? We didn't even set the value at all. So it's saying years left in college is 22. So you can see that there's maybe some more logic that's needed. Because what if age hadn't been set at all? Then uh, then this really doesn't make sense, because you know you're 18, but maybe it happened to be that we didn't tell that object that you were 18, and then we go ahead and use this method, and all of a sudden it's calculating the wrong value. So um, so like we could for example we could give it some kind of error state, like we initialize the years remaining in college to you know minus 99999. That's definitely an error state. And then we can say self.age, like if that exists. So sort of a conditional. If hmm, um, not equals nil, maybe. Then we do our calculation. Well, let's see what kind of warning it's giving us. Comparison pointer and integer. Ooh. So it doesn't like this comparison. So an integer, you don't want to compare an integer to nil. So for example, if age does not equal 0, in other words, it hasn't been set yet, because I think maybe it'll default to 0. Oh, okay. So we ran that, and now it's giving us the error state. So we never set the age, and at this point we never set the age because we commented that out. And so here in our implementation, it's saying, hey, age hasn't been set. It's 0. And then we just initialized this years remaining college to this crazy number. So that's definitely an error. But then let's go ahead and put an age back in there. Like, let's say rewind time here 16. Let's run that. Okay, now it's saying 6. So it's 6 years until you reach 22. But we'll go ahead and put it back to the 18 state. And there, we can see it calculate the 4. So, there's lots we can do to kind of perfect this so it's sort of scientifically accurate or something. But you get the idea about how we can start to build methods, build on top of that complexity, and in a way simplify our lives, because that kind of calculation is going on within the method of our custom class. So I think that wraps up this section of the learning.